This is Caddis. Caddis is one of the world's best dermatologists and brilliant in detecting skin cancer. However, Caddis is not able to speak, nor can he move his body. Most importantly, he does not share any common concepts with his dermatologist colleagues. All of this leads to trust issues and questions of accountability in all involved stakeholders like patients, colleagues, and authorities. As you might have already guessed, all of those issues are the case with current deep learning-based CAD systems, short for computer-aided diagnosis. And this constitutes a major barrier in their clinical deployment to support doctors. Melanoma is cancer that develops in the skin. According to the Skin Cancer Foundation, more than 2 people die of skin cancer in the US per hour. The disease often develops from the resembling benign mole, and the progression of the disease is often asymptomatic. However, after some time the cancer can spread through the blood and lymphatic vessels, leading to a patient's death. Therefore, it is crucial to detect the disease as early as possible. Currently, melanoma is diagnosed by experts that have gone through years of training. They apply techniques to discern between complex structural and coloral patterns on the skin lesion that can either be benign or malignant. Examination of a single patient with many moles takes a doctor time and effort, maybe resulting in reduced thoroughness of examination and shortage of availability for patients in need. Lastly, a diagnosis from a human doctor is always subjective and depending on his or her mood, as well as other influencing factors. Therefore, the aim is to augment human doctors by AI systems that facilitate the complex recognition, speeding up their routine work, and introducing reproducibility and objectivity. This requires the AI to provide explainable diagnoses that are comprehensible by those experts. My name is Adriano Lucieri. I'm PhD student at the German Research Center for Artificial Intelligence and TU Kaiserslautern. In our work, we asked ourselves whether an existing skin lesion classifier uses similar concepts to those that are being used by doctors, and whether the AI is using those concepts in the right way. Therefore, we adapted the concept-based explanation method TCAV for the use with IID data. We used TCAV to investigate the similarity and influence of concepts used by the public record classification model that won the 3rd place in the IJCNN 2017 challenge. We found that comparable concepts to those used and defined by dermatologists are actually used within record, and that they influence the predictions in the right way. The original method works as follows. We first train an arbitrary DNN architecture on one arbitrary task using a class-annotated train dataset, for example a network distinguishing zebras from horses. Then we try to act as a translator, translating the cat's language to something understandable to doctors. Therefore, we present abstract examples of concepts to the network, like, for example, the concept of stripedness or brown color. We see if the network is able to distinguish between those conceptual samples and know, therefore, whether those concepts have been learned. For this concept training, we collect an OOD dataset of abstract concept samples, for example striped fabrics. We feed those images to the network and extract the intermediate flattened activations. Those vectors are then used to train a linear classifier to distinguish between samples containing a concept and the rest. Low test accuracies indicate that the network has not learned a concept, while high accuracies indicate that it is able to detect this concept implicitly in its inner representation. Using linear classifiers has the benefit that we don't need many examples to train a concept, and that we get a vector that points into the direction of the learned concept. Those vectors are called concept activation vectors, or short CAV. This CAV can be used to compute the TCAV score, which quantifies the contribution of a single concept towards the prediction of a single target class. It does so by measuring the sensitivity of all samples in the direction of the concept. Therefore, it can use a set of data to approximate global explanations. This plot indicates that a high value of the TCAV score for concept striped means high influence on the prediction of the class zebra, whereas the concept brown results in a low TCAV score and thus negative influence. But hold on, how are we supposed to abstract the complex structural and coloral patterns present in skin lesion images? That is not straightforward. Therefore, we adapted the method to train concepts on IID data. As already mentioned, we did our investigation on a module of RECORD, a public model that has already been trained on IJCNN 2017 data to classify nevus, melanoma, and a third disease class called seborrheic keratosis. In order to train concepts, we used DERM 7-point and PH2 datasets, which contain binary labels for many dermatologic concepts used by doctors, such as pigment network structures or the coloral blue-whitish veil. The reported results are separated by dataset, as the datasets contain some differing concepts, and it was not guaranteed that the definitions of same annotated concepts coincide. The concept similarity can be confirmed by looking at the validation accuracies of concept annotated samples. For the two datasets, it is clear that most of the linear concept classifiers achieve detection rates above random guessing. The best accuracies have been achieved on one of the last conf layers, namely mixed 6H. This indicates that the concepts defined by doctors are of high level complexity. The concept training and testing data contained balanced number of samples. The concepts from PH2 that achieved near random accuracies were excluded from further investigation. The concept influence plot shows which concept contributes to the prediction of which target class. The TCAV score evaluation has been performed on the independent trained set of IJCNN 2017 containing 600 samples. For DERM 7-point, we can see that concepts that are related to benign lesions in literature also indicate benign classes and vice versa. Pigment network typical, for example, is a concept typically seen in nevus. RECORD's prediction of nevus is positively influenced by this concept, whereas melanoma isn't. Regression structures is a concept that indicates malignancy, which is also reflected in the influence scores for the deep learning model as seen here. Same trend can be observed in concepts trained on PH2 data. Here we see that symmetry is very indicative of nevus, but asymmetry in two axes and the presence of many colors in the lesion indicate melanoma and seborrheic keratosis. It needs to be noted that results for seborrheic keratosis need to be interpreted with caution due to the low number of samples in the concept training set. Wrapping it all up, we've seen that the concept-based TCAV method does not only work with abstract OOD data, and that it can be used to explain skin lesion classifiers. Examining the RECORD model, we found that its inherent concepts share some similarity with the ones defined by humans, and that the influence on their prediction aligns with the descriptions in medical literature. Caddis is still a good doctor because the TCAV method that we used is a post-hoc method. However, we somehow resolved the conceptual barriers with his colleagues. Also, we let him explain his decisions by indicating the global tendency of a concept toward a diagnosis class. We have also been working on generating concept-wise heat maps to localize concepts learned by a deep learning system in further work, for those who are interested. And also feel free to have a look at our online demo for the dermatology use case on x8.kl.dfki.de. In order to apply those methods meaningfully with the aim of practical deployment, it is need of the hour to properly define a set of relevant concepts for the diagnosis of diseases and annotate a sufficient amount of diverse data according to those definitions. Thank you for your attention.